In the high-stakes world of artificial intelligence, one company didn't just win the race, it rewrote the rules 15 years before the race even began. While the world watched generative AI explode in 2023, NVIDIA was already sitting on a multi-trillion-dollar empire. And its biggest rival? AMD, once a scrappy challenger, was left scrambling in the dust. This is the story of how NVIDIA didn't just beat AMD in AI, it killed its chance to compete before AMD even knew the battlefield had changed. To understand how this happened, we have to go back, way back, to the 1990s. NVIDIA was born in 1993 with one mission: offload graphics from the CPU. Their founder saw that 3D rendering was choking general-purpose processors, so they built a new kind of chip, the GPU. In 1999, they launched the GeForce 256, the world's first true GPU. They didn't just sell hardware, they sold a vision: parallel computing for everyone. Meanwhile, AMD had a completely different origin story. Founded in 1969, AMD spent decades locked in a brutal war with Intel, fighting for scraps in the x86 CPU market. Its identity? The perpetual underdog, the value play, the second source. While NVIDIA was dreaming of supercomputers in every PC, AMD was fighting for survival, one CPU socket at a time. And that difference in DNA, it would decide everything. The year 2006 was the fork in the road. On one side, NVIDIA launched CUDA, a quiet, almost invisible software platform. On the surface, it let scientists use GPUs for math, but in reality, it was a Trojan horse. CUDA turned gaming GPUs into general-purpose supercomputers, and NVIDIA made it easy. Write code in C or Python, and boom, you had access to thousands of cores. But here's the genius. NVIDIA made CUDA work on cheap gaming cards. Students, researchers, hobbyists, they all learned on GeForce GPUs. Then, when they got jobs at Google or Meta, they demanded NVIDIA in the data center. It was a decades-long recruitment strategy disguised as a software tool. Now, look at what AMD did that same year. It acquired ATI. Why? Because it had no choice. It needed GPUs to compete with Intel's integrated graphics. It needed a full CPU plus GPU stack to survive. But that acquisition was a hardware play, all about chips, drivers, and product cycles. While NVIDIA was planting seeds for a forest, AMD was fighting a forest fire. And the cost? AMD had no resources left to build its own CUDA. The die was cast. Even in hardware, AMD was playing from behind. After buying ATI, it inherited the Terascale architecture, built for graphics, not AI. It used VLIW, a design that bundles instructions for parallel execution. Great for rendering pixels, terrible for unpredictable AI code. When deep learning arrived, Terascale stalled. Compilers couldn't keep its execution units busy. Silicon sat idle. Performance lagged. AMD knew it had to change, so in 2011, it launched GCN, a new architecture designed for compute. It was a massive engineering feat. It powered the PlayStation 4 and Xbox One. But even GCN had a fatal flaw for AI. It couldn't scale deep neural networks. Researchers found models on GCN over-smoothed after just 3 or 4 layers. Information couldn't flow through the network. AI hit a wall. Meanwhile, NVIDIA was doing something AMD couldn't: co-evolving hardware and software in real time. Because of CUDA, NVIDIA's engineers talked directly to AI researchers. They saw the bottlenecks firsthand.
So when matrix math became the heart of deep learning, NVIDIA didn't wait. It built tensor cores, dedicated AI accelerators inside the GPU. This wasn't luck. It was a virtuous cycle. CUDA to real-world AI use, to hardware feedback, to better GPUs, to stronger CUDA. AMD was reverse engineering a revolution it didn't see coming. Then came 2012, the big bang of modern AI. At the ImageNet competition, a team from the University of Toronto stunned the world. Their neural net, AlexNet, crushed the competition by training on 2 NVIDIA GeForce GTX 580 GPUs using CUDA. Overnight, every AI lab on Earth asked one question: where do we get NVIDIA GPUs? And because CUDA was the only mature platform, frameworks like TensorFlow and PyTorch were built for NVIDIA first. Switching to AMD meant rewriting code, debugging drivers, losing weeks of research. No one had time for that. NVIDIA didn't just win the hardware war, it owned the software stack, the libraries, the tools, the talent. By 2020, over 2 million developers were in the CUDA ecosystem. AMD's ROCm, a fraction of that. Let's talk money. In Q1 2023, NVIDIA's data center revenue was $4.28 billion. Just 2 years later, $41.1 billion. That's a tenfold increase, while AMD's data center revenue barely tripled to just $3.2 billion. And in the gaming GPU market, the on-ramp to AI development, NVIDIA now owns 94% of the discrete GPU market. AMD, just 6%, down from 12% a year ago. Why does that matter? Because every student learning AI today is learning on CUDA. They'll demand NVIDIA at their first job. They'll build startups on NVIDIA. They'll train the next generation of models on NVIDIA. It's a self-reinforcing loop, and AMD is outside it. But don't count AMD out yet. Under CEO Lisa Su, it's made a stunning comeback. Its Instinct MI300X has 192 gigabytes of memory, more than NVIDIA's H100. It runs Llama 3.1 405B, the world's largest open model, exclusively on AMD. Meta, Microsoft, and OpenAI are all testing AMD at scale. Why? Strategic diversification. No one wants to be locked into one vendor. But here's the catch. Even when AMD's hardware wins, its software loses. Developers still complain about ROCm. Hard to install, unstable on consumer cards, lags in framework support, requires extra engineering hours. As one analyst put it, the CUDA moat has yet to be crossed. For enterprises, time is money. Saving $10K on GPUs isn't worth losing 3 months of engineering time. NVIDIA knows this, so it's not stopping at chips. It bought Mellanox for networking. It builds entire AI supercomputers, DGX, GB200. It sells enterprise software, cloud services, even data center power standards. NVIDIA isn't a chip company anymore. It's an AI operating system. AMD's counter? Openness. ROCm is open source. It's upstreaming into PyTorch and Triton. It's betting that the world will reject NVIDIA's walled garden. But ecosystems aren't built on ideals. They're built on ease of use, reliability, and network effects. And NVIDIA has a 15-year head start. So how did NVIDIA kill AMD in AI? It wasn't faster chips. It wasn't better marketing. It was a 15-year bet on software when no one else believed. While AMD fought yesterday's wars, NVIDIA was building tomorrow's platform. And in the age of AI, the platform wins. AMD isn't dead, but to survive, it must do the hardest thing in tech: build an ecosystem from scratch while racing a locomotive. The question isn't whether AMD can make great hardware. It's whether it can make developers love its software. Until then, NVIDIA reigns. If you found this deep dive valuable, hit like, subscribe, and turn on notifications, because in the next decade, this battle will define the future of computing.